So, good afternoon, all. And today's lab experiment. The aim of this experiment is to record and analyze the electrical activity of the heart using the electrocardiograph. So, let's get started. So, electrocardiograph. It is an instrument that records the electrical potential changes occurring during the heartbeat. The electrical activity of the heart causes the heart muscles to contract that results in the pumping of the heart, and the graph on which the electrical activity is recorded is called electrocardiogram. It is a non-invasive diagnostic tool for detecting heart conditions. It can help in detecting many heart predictions which can be helpful for patient's health. Now the electrical conduction system of the heart. In this, the SA node or sinoatrial node acts as the heart natural pacemaker by initiating electrical impulses that regulates the heartbeats. Now, next is after SA node, the signal is transferred to AV node, which acts as a delay, which is also called atrioventricular node, which delays the electrical impulses from the SA node to ensure the atrial contracts before the ventricles. Now, next it goes to the bundle of hits. It is present in between both the ventricles, left and right, and it transmits the electrical impulses from the AV node to the ventricles, facilitating synchronized contraction. Next is a Purkinje fiber. It presents on the heart wall or near or mostly near to the ventricle outer walls. This fiber rapidly conducts electrical impulses throughout the ventricle, ensuring coordinated and efficient contraction. Next is how this cycle works. Now, as the signal is generated from the SC node, a P wave generated. Due to the delay is causing a baseline in the P in the PQRST wave. Next, after the AV node contraction and it transfer to the bundle of his, we got a QRS complex. Then the QRS complex, on transferring this electrical signal to the bundle to the Purkinje fiber, it takes time, and in that time we observe a flat line. Next, uh, when the contraction of the ventricles happen, then we observe a T wave. Next, after the T wave, when the relaxation period comes, it follows through a baseline. Then again the process starts again repeatedly. Now the electrode placement. For the ECG recording, there are two types of system: limb leads. In this limb leads, four limb leads are being connected in the right arm and in the left arm. Right arm mostly red in color, and in the left arm it's in yellow in color. Similarly for the right ankle, right right leg and left leg, and and the right leg is called the right leg. It's near the ground, and it shows the ground, and black is the neutral lead, and it's present on the left leg. Next is the precordial chest leads. V1 fourth in present in the fourth intercostal space, right sternal border. V2 fourth intercostal space, left sternal border. V3 V4 is present on the fifth intercostal space, mid clavicular line. V3 is present in the midway between V2 and V4. Then V5 placed, which is same horizontal level as V4, anterior auxiliary line. V6 same horizontal level as V4, but in the mid auxiliary line. Next goes the components of the ECG machine. It includes the electrodes, which detects electrical signal from the heart surface. Seconds are the lead selector, which chooses which specific electrode combination need to be there. Third is the amplifier, as the signal are weak in nature, so we need an amplification to get the better signal output. Fourth is the isolation circuit. It ensures patient safety from isolating the patient from the main electrical circuit. So if any hazardous condition happen, the patient is being safe from the electrical supply. Next is the recorder and printer, which can convert this electrical signal into visual graph or printing the ECG waveform. Next is the microcontroller, which process and analyze the ECG data, providing automated interpretation. ECG wave component. We can already discuss that P wave is due to the atrial depolarization. QRS complex is due to ventricular depolarization. T wave generated due to ventricular repolarization, and U wave is additionally presented due to the repolarization process of the atrial. Next is the application of ECG. Application based like diagnosing cardiac condition, which includes arrhythmias, myocardial infarction, and heart blockage, which it's also include in the monitoring system as well during the surgeries, stress test, and in critical care units. Next is the advantages and limitations. The advantages of ECG is it's non-invasive, quick and easy, and portable diagnostic tool. What are the limitations does the ECG have? It is a limited scope. It only records the electrical activity information, not a physical one. Second is the false positive and negative. We can misinterpret the results. So this is also come under the limitation part. Artifacts and suspect artifact susceptibility. This due to the movement or poor electrode placement or external electrical interface can distort readings. Yeah. So here are my references for this presentation.